The Indian Association of Structural Engineers, also known as IAStructE, was conceptualized and constituted in the year 2002 by a group of senior professional structural engineers from all over the country. IAStructE is registered under the Society's Registration Act 21 of 1860. IAStructE is a national apex body of structural engineers in India with a mission to promote structural engineering profession and cater to the professional needs of the structural engineering fraternity. In the short span of 2 decades, association has attained an eminent position in the professional field. Its membership is valued very highly in the profession. Since inception, IAStructE has been led by eminent structural engineers like late Shri Mahendra Raj, late Shri Kumar Ghosh, late Shri Subhash Chand Mehrotra, Professor Mahesh Tandon, Shri Manoj Mittal, Professor R. Pradeep Kumar and Shri Alok Bhaumik as its president. IAStructE is a permanent member of Engineering Council of India and interacts with the government on professional and policy matters related to civil and structural engineers. To expand its reach, IAStructE has collaboration with various international professional like-minded associations and institutions like IAStructE, UK and FIB for strengthening global connections and professional exchange. IAStructE's prime objective is supporting and protecting the profession of structural engineering by upholding professional standards and acting as a mouthpiece for structural engineers in India. IAStructE endeavor to ensure that its members develop the necessary skill in structural engineering and work to the highest standards by maintaining a commitment to professional ethics and standards. IAStructE is actively engaged in organizing several continuing professional development (CPD) courses for structural engineers to help them update their knowledge and advance their career paths. It also conducts refresher courses for young and practicing engineers and student-oriented programs. Seminars, workshops, conferences, technical lectures and discussions related to the latest technological advancements and case studies are also organized regularly for members to enable them to continuously update their knowledge and skill set by interacting with the best minds from the industry. IAStructE's activities are widely appreciated and known for quality technical contents. IAStructE is also actively engaged in publishing its quarterly journal Structural Engineering Digest (SED), code commentaries, professional guidelines, monthly newsletter, and Crossfall, a unique quarterly newsletter that confidentially reports structural failures and the lessons learned from them. IAStructE's publications are becoming popular with time. IAStructE has representation in various technical committees of BIS and IRC as well. Its members are actively contributing to National Code of Formulations. In the year 2020, IAStructE started National Awards competition to stimulate interest in the structural engineering field and to promote innovative thinking and creativity. The awards are presented to the winners in recognition of their outstanding contribution to structural engineering in the categories which include Outstanding Structure, Outstanding Structural Engineer, Outstanding Woman Structural Engineer, Promising Young Structural Engineer, and Best Master's Thesis in Structural Engineering. Reaffirming its commitment to professional excellence, IAStructE launched the accreditation program in 2023. This flagship initiative empowers practicing engineers to evaluate their competencies, identify growth opportunities, and strengthen the foundation for sustained professional success. IAStructE is currently operating from 4 regional centers, namely Eastern, Western, Northern, and Southern, having its headquarters in Delhi to inculcate the professional culture and provide handholding to the budding engineers. Joining IAStructE offers exclusive resources, mentorship, and networking with industry leaders. Members enjoy discounted registration for workshops, seminars, and events, along with discounted membership of FIB, opportunities for certification, career guidance, leadership roles, and enhanced professional recognition. IAStructE has its student chapters in several leading engineering institutions as well. Membership of IAStructE is open to all civil and structural engineers engaged in structural engineering profession. Members are elected based on their qualifications and experience in different grades as per eligibility requirements prescribed in the bylaws. Each application is carefully scrutinized before electing the members. More information about IAStructE is available on its website www.iastructe.co.in.
Hello. Vikas,
Yes, sir.
my
Dhawan
voice
sir,
is
please.
audible?
Yeah,
My
sir.
voice
Please
is
start.
audible?
Yes, sir. Yes.
Dear friends, welcome all of you for joining the webinar. Topic of the webinar today is planning and design of underground metro stations using the new Austrian tunneling methods. On behalf of the Indian Association of Sector Engineers, we thank Engineer Partha for agreeing to present on the above subject. Engineer Partha graduated from very eminent college, Shivpur Bengal Engineering College in 1997, and thereafter, as practicing engineer, he did his MTech from IIT Delhi in structural engineering. He has over 28 years of experience in planning and design of bridges, metro systems, and complex structures. Currently, he is Director Technical, Ayesa India Private Limited. He is very active in associating with Indian Road Congress Committee. At present, he is the chief editor of our quarterly journal, Structural Engineering Digest, and very actively involved with the development of various technical documents published by Indian Association of Structural Engineers. About the webinar, the brief of the webinar is already available through the flyer, but underground metro construction has become unavoidable in densely populated and congested urban areas where land availability is scarce. The new Austrian tunneling method is increasingly being adopted in certain metro projects as it allows underground tunnel construction with reduced surface excavation and improved construction flexibility to avoid large-scale open excavation. The presenter shall discuss the intricacies involved in the planning and design of underground metro stations constructed using NATM, including geotechnical considerations, construction sequence, and risk mitigation strategies supported by relevant case studies. Now to Engineer Partha to proceed, please.
Thank you. Thank you, Dr. Dhawan. First of all, I would like to thank IAStructE and Mr. Dr. Dhawan to give me a chance to talk in a very, very interesting topic. In present scenario, basically, in few of the cities where there is a space is not available there, thus the NATM has been used to construct the underground metro station. So, is my screen is visible?
Yes, sir. Yes, sir. Visible,
Yes.
sir. Yeah, please make it in full screen, sir.
Okay, okay, okay. So, already Dr. Dhawan has explained you the topic of the today's presentation. Okay. First of all, good evening to all of you. Good evening to all of you for attending today's webinar. So I will cover today the first of all the underground metro conventional approach and why the NATM has been proposed, and planning of NATM stations, and different aspects of NATM construction, because although it is a it is a design and planning and design of NATM construction in station, underground station, but I'd like to emphasize that the without construction aspect, design of NATM is not feasible. Basically, it's when I'll go with the presentation, it will be clear how construction aspect is very much important in case of NATM construction. So I'll go for a case study where Mumbai line Metro line 3, there is a particular one project where we are the consultant, detailed design consultant. We'll go to a case study, and after that the conclusion. So coming to underground metro station conventional approach, basically the conventional construction and planning of underground station is emphasized with cut and cover construction technique using either top down or bottom up construction. So what happens? This is underground stations. It's a typical underground stations where you can see this is a picture of construction technique of underground station normal. So it has been done. What has been done? This we need to cut this and then make the station and fill it up. This is the conventional approach, but this conventional approach can be done with top down or bottom up, depending upon whether it is a on-road station or off-road station, or as per the geology of the geological condition at the site. So generally, all road station has been done with a top down to minimize the disruption of the traffic. Okay, so this is a top down construction approach, and bottom up method has been done where the rocky strata is available at higher depth, shallow depth, that is at the, if this is a concourse level, if we are getting the rock at higher level, then bottom up construction, or we can go for a, if it is an off-road station, then we can go for a bottom up construction. But generally in off-road station also, we don't prefer to go with a bottom up construction, because if water level is high, then we need to put a second pile retaining system and start retaining system, which has an additional cost to the projects. So in case of top down construction, it's very easy. First we have to do the diaphragm wall, and then planche column, pile and planche column to support, then excavate the top portion up to the bottom of the top slab, construct the top slab, then excavate up to the concourse level, cast the concourse level, then come to the bottom of the base level, excavate up to base level. So, and if tension pile is there, we need to provide tension pile. Tension pile is mostly required for buoyancy. In case of top down construction, generally tension pile is not a common thing, because this diaphragm wall and the pile below the planche column can take the tension in general, unless the station depth is very high. So after that, we have to construct the platform, and we have to fill up later, or we can have if it is an on-road station, generally after the top slab constructed, we have to fill the soil, and road will be plying. And we have to keep the few temporary cutouts at the roof concourse to basically remove the excavated materials from the station body area. And in case of bottom-up construction, as I say, here you can see this portion is soil, and from this portion rock has been started. So rock is grade 4 to 5 rock. That means it is a very weather rock, and here grade 1 to 3 rocks. Here what we have to do, we generally put if water table is basically below the base level, then we may go with a soldier pile construction. But if water table is high, here we are showing the second pile. Second pile has to go up to the rock, which is at least grade 3 to avoid any seepage or avoid any water leakage during the construction. So after that, we will come to excavate up to the start level 1. We will put the start level. Meanwhile, king post should be there, because this is a half portion of the station. Otherwise, the king post is required for different purposes, like to break the strut length, or to have a gantry also over for excavation purpose. We may have to have a gantry running along the station. And sometimes it is a off-road station I have shown, but if it is an on-road station, there may be half portion, there may be a decking to be provided so that traffic can be moved during the construction. So here, after that, we need to put the steel strut layer. Somehow in steel strut layer has been removed or replaced by anchor. A rock anchor, you can put a rock anchor instead of steel strut. And rock anchor, it is a bit construction-wise, rock anchor is a better thing, because you will get entire area free for construction. And after that, this is sequentially, you have to go for second strut, third strut, or second anchor, third anchor. Okay. And after that, when we have got a farm rock 3, we have keep a berm and cut open excavation with a 90-degree or a 85-degree angle, depending upon the geology and availability of the spaces. So here generally we use the shotcrete and the rock bolt. The rock bolt and shotcrete, basically this rock mass is self-stabilized and it has been checked during the design, and this rock bolt and shotcrete has been provided to have any loose basically joint tears. Rock mass should not be fall out. So after that, we need to cast the bottom slab, concourse slab, and top, and we need to remove the strut, and ultimately we need to cast the top down construction and then fill up. So this is the construction sequence of a bottom up, although I will not go much detail into this, because this is not the topic for today's discussion. But I just want to show first conventional, then NATM. Now let us understand the key factors that drives the adoption of NATM in urban underground construction. Basically, in NATM is it is not a new method. It is a very old method used for a tunnel in rock mountain, like Himalayan tunneling and Kashmir, and NATM, and different where, not only Himalayan, everywhere NATM has been used for a road tunnel, railway tunnel. There is no issue of that. In general, for underground metro construction, since it is urbanized, Okay, and we required a very fast construction. That's why TBM tunnel, mechanized tunnel boring machine, TBM tunnel has been used. It is very popular. So that's why in tunnel we don't use the NATM in urban environment in general. In general, I am telling in general. But now we have to see why this NATM is proposed in urban construction. Basically, NATM is based on the principle. What is the principle of utilizing the inherent strength of the surrounding ground and supported it through a control and sequential excavation process. This is the generally principle of NATM. So what are the driving forces? In highly congested urban environment, where there is practically zero tolerances for surface disruption, any conventional open excavation would severely impact traffic and daily city operations. There might be major utilities running through the city, such as maybe water lines, sewerage lines, network, and electrical systems. Relocating or disturbance of this utility is extremely challenging and risky. And another critical issue may be the presence of heritage and old structures where strict settlement control is required. Even minor ground settlement can lead to structural damage, which makes control excavation essential. Additionally, open cut excavation is often infeasible due to the limited space availability and heavy traffic constraints in dense city areas. When I will explain the case study of today's case study, I'll show how it is open cut is not possible in the particular situation, so that NATM has been used. So there may be a variable geology in Mumbai, where I am telling it is a weak to strong rock has been available during the construction. So in NATM, another thing is there. A support system can be adaptive. Basically, depending upon ground behavior, we can change the support system during the construction. And geology generally rock strata, it's allow to adapt NATM construction. However, in soil condition, particularly within a congested urban environment, NATM is generally not preferred, because in soil, what happens? You don't have a inherent strength of the soil like rock had. So problem is that we required a extensive ground improvement. It's too much of costlier. And another problem is that in urban densely populated area, it's very difficult to get space to do a ground improvement from the top. So it's very difficult for that. That's why in soil generally big type of cavern NATM is not preferable and also not desirable. So in addition to this, there are some other technical advantage also. The method also involves sequential excavations, which helps in achieving the control deformations that I talked a control deformation in the first part in urban environment. I will discuss it later about sequential construction during the construction when I will discuss about construction. It is also fully compatible with real-time monitoring and observational method. Basically, you can assess the ground movement, ground reaction by means of a monitoring and instrumentation and monitoring, and you can change your support system. You can continuously change your design system based on the ground reality. And basically, overall NATM, sometimes NATM is most suitable solution for construction of large underground cavern, particularly in urban space constrained urban environment. So now coming to planning of NATM station, basically if we go for the tunneling is cut and cover tunnel that we know, we cut it and make the tunnel and that fill it. TBM tunnel, this is very much, it has been used for at least all the metros in India, which has construction, whether it is a rock or it is a soil, we are using the TBM. And NATM is the cut and put the support. cut and put the support. This is the NATM construction. So if I am going to the NATM station, so I have shown you a typically, it is a typical 3D model of a NATM station where you can see these are the curtain cover boxes. Curtain cover is required because you need to bring the whatever excavated material is there in the NATM. You need to bring it to the ground level for a disposable. So here you can see these are two tunnel. These are the platform NATM tunnel, and this is the central station tunnel, and these are the curtain cover box. Because NATM, we cannot make a very big NATM, so all the station services room generally we fit in the curtain cover box wherever we get this. And there is a access tunnel, main tunnel, because you are entering into the station and go ticketing. After that you are coming to the platform, and for platform you need to go to this you need to go platform level central station tunnel. You need to go to the platform tunnel, so you require certain cross audit or cross passages to go from central tunnel to the access tunnel. So this is main platform tunnel, and this is a photo where this has been already done. One station has been done with a NATM. It is not in India. It is from out of India, and this is the platform tunnel where all the utility has been provided. So this particular things is entirely from services and architectural look forward. But yes, structural or geotechnical engineer. Another thing I want to emphasize: NATM design is a part of a soil structure introduction. So one has a geotechnical knowledge also and structural knowledge also. Both blended with both structure and geotech will have a very good NATM or tunnel engineer. So coming to seconds, these are the basically cross passage as I show you. In the last slide, these are the cross passage tunnel, which is also NATM. These are the cross passages. So here there is a platform access, and there may be another access with undercroft also, because all the services should come from central station tunnel to the platform tunnel. For that you need to have a separate tunnel. So you may have a two type of audit in the station. So this is the cross section. What we have seen the cross section at the audit location. These two are platform tunnel, and this is the central tunnel, and these are the audit location. And here you can see this connection at undercroft level for services has been also shown in this picture. So this is the concept picture prepared by the architect, and this is a 3D beam model view just to show how the station has been conceptual. So this is you can see this is a platform. We have tried, this is a TBM tunnel. So we first try with a very less area, so that excavation will be lesser, cost will be lesser, construction wise is better. But you can see we cannot get it is insufficient OT area. OT is it is required for ventilation purpose of the station and the tunnel, and here no spaces is available. So we need to insufficient your service area. So we need to increase this tunneling actually this section. So now coming to another section, you can see the section has been increased, and we could able to used all the equipment. The OT duct area is sufficient. The equipment, whatever equipment is required, whatever the services requirement, drain area, all has been provided with this NATM. But it is a bigger one than what we have started with. So you can see all the SNT electrical, SCADA, power supply, track drainage, everything has been accommodated in the in this NATM platform tunnel. So now, as I say, the design is cannot be isolated without the sequencing of the NATM construction. So we'll discuss about NATM construction. So now the construction basically is begin with a very careful excavation in small sections. If you can see, first this was the TBM tunnel which has been through. It helps to get this much of excavation has been done, and after that we are enlarging this with the NATM method. So here first generally we construct with the heading and benching method. So this is a heading method. You can see this is heading, and this much portion is called benching. So this is the geometry of the complete section, and this is the geometry of the heading section. And you can see this primary support will show primary support system. We did immediately after that we provide the primary support system. Primary support system is mainly shotcrete, wire mesh, rock bolt, and sometimes steel ribs or lattice girder. So here you can see there is a lattice girder has been provided here. This is the lattice girder inside the shotcrete. It basically give the strength of primary liner. If primary liner is basically ground is weak, then we need to provide this shotcrete. Sometimes we need to provide a 4-pole also. I will go in the case study about the 4-poling and the primary support in more details basically. Now, as I saw this is the longitudinal section. This is the cross section basically. This is the cross section. Now I am going for a longitudinal section. In case of longitudinal section, you can see that tunnel has been advanced like this. So here this color is indicated as a heading, and this is a benching. So you can see heading and benching, there is a difference in excavation basically along the length of the tunnel. So here you can see there is 3 in advancement. It is called advancement. One portion is advancement. Basically, we try to construct like this. First, we construct one advancement, then another advancement, then another advancement. After third advancement, we started the benching. Now in heading also, I have made a different color of the heading. So this much, this much, this much, this much. Basically, we are also constructing one heading also in 4 part or 5 part, depending upon the geometry, the geology. If we have a very poor geology, poor rock, then we have to make it very small spot so that the ground settlement is not the very high. Okay, and as I told, it is a very sequential excavation, as I told in the first 2 slides. So this is called the sequential excavation with small advancement. You can see this 4-poling. We put the 4-poling like this, 4-poling. So it will also enhance the top ground, the ground above the NATM tunnel, which is like you are stitching the ground to give a improvement of the strength of the ground. So in case of soil, what I am discussing, in case of soil, you may require a entire ground improvement, 3 meter, 5 meter, depending on the soil condition and this. And if at the top there is no space available for ground improvement, it's very difficult to have a ground improvement proposal in case of soil. And ground improvement not only is a basically difficult approach, it is also a costlier. suppose you have a sandy soil. So in sandy soil, your ground improvement, if you are thinking it is a 5 meter wide, it may go to 15 meter. You never know where your grout is going. And in case of clay soil, it's very difficult to have a grouting in the clay soil because the permeability is very less. So you may have to go from chemical grout or and it's too costly actually. And here also I want to tell this water pressure has been released for primary system. Okay, its primary system we have approached, we have released the water pressure so that in primary lining the water pressure has not be a governing force to the things. But in case of water pressure release, there is a problem of the groundwater table lowering. That also I will explain. Based on the groundwater table monitoring, we need to have a recharge well from the top, and we need to continuously recharge from the ground so that groundwater table drawdown will not be higher than the as stipulated in contract or for design requirement also. Otherwise, what will happen in the ground? The soil will be the structure will be settled and there will be cracks. So to avoid it is also required. And you can see there is in heading there is a elephant foot has been provided. This is basically I am showing in a very poor geology, because this elephant foot will transfer the load coming from this ground to the primary lining, and it need a base. Okay, and it has been again when I am going for a benching, it has been the lattice getter has been extended up to the bottom. So and a very key features of the NATM is the observational approach, because this all the primary support system can be modified based on the actual site condition, based on the real-time monitoring data. And for this purpose, instrumentation and monitoring system are installed to measure parameters such as ground movement, settlement, and stresses. Based on this observation, this can be optimized, this can be increased for the primary support. And I'll talk about later about the monitoring also. And as I told, it is a very controlled. We can have a controlled deformation because we are doing in a very small excavation. Unlike the open excavation, you are doing entirely open excavation. We can have a very controlled thing. Once the primary lining has been basically constructed, we do the permanent lining. This is the line of the primary lining. I am not. It is in basically dotted line. So usually it is in reinforced concrete. It is provided as a long-term stability and durability. Here we will mainly discuss on actual primary lining only. Secondary and primary lining, generally it will be effective if temporary lining is failed. Basically, if you look into that, temporary lining is good enough to take care of the ground load, but secondary lining has been provided for a durability purpose, because people has a apprehension it did shotcrete, and this may not be the intact up to the service life, that is 120 years. So I'll go to the case study now for a Mumbai. With this background, I will go for a case study, Mumbai Metro Line 3 UGC02 projects. So first go to overview. Basically, this is a project corridor from Kolaba to Bandra. Sorry. Total length of the project is 33.5 kilometer, and total number of stations is 27, and client is Mumbai Metro Rail Corporation, MMRCL. Here our part is from we are discussing with UGC02. This red portion is our portion. There is 4 stations, namely CST, Kalbadevi, Girgaon, and Grand Road station. So, what is the scope? Scope is the for 4.0. As I told, these are the scope. This is a 4.05 kilometer of tunnel. Total station 4. Number of crossovers 1, and number of cross faces is 7. Cross faces build the fire require. It is a fire evacuation requirement between the two tunnel, so that if there is a fire in the single tunnel, then evacuation can be done by the another tunnel. So it's basically it is the Indian most complex underground metro alignment with its heritage building, and I would say here there is no only 2 TBM has been operational for single project, because in between the space is not there to basically launch or retrieve the TBM in between. So here from CST station, the TBM has been launched, and it has been basically retrieved as Mumbai Central Station for this project UGC2. So why Line 3 metro projects are unique? Because to begin with, that this is a basically 33.5 kilometer fully underground corridor, which is the first project of this scale in the India, fully underground. The alignment passes highly congested urban areas, including zones with seismic and sensitive structures. Basically, construction is extremely challenging in terms of safety of and settlement control. And another achievement is there, okay, that 17 TBM most missing operation simultaneously, which is a record in Indian tunnel history in these projects. And there is an integration of different construction methodology like TBM, NATM, curtain cover, and depending on the site condition. Additionally, advanced settlement monitoring system and specialized heritage protection measure was implemented in this project to ensure that existing structure remain unaffected. Overall, this project represents a benchmark in terms of engineering complexity, planning, and execution in urban underground construction. So now coming to our UGC 02 projects, why it is also focusing, this package also has its own distinct or critical challenges. The project corridor were extremely congested with very limited working space, with significantly restricted construction activity. Geologically, the presence of weak breccia rock with low strength and poor to fair rock mass quality add to the complexity of construction and support design. And it is a very critical constraint was the strict settlement limit of less than 25 millimeter, because there is a sensitive and deliberated building. I will come to some portion of building damage assessment also in my presentation. And basically, due to all these constraints, open excavation method was not feasible. So NATM has been adapted as a suitable solution. So to ensure the safety, FEM-based sequential excavation analysis has been carried out, and with precise prediction and control of ground behavior during the construction. In summary, UGC2 contract is a strong example of how engineering innovation and adaptive construction technology can successfully address highly constrained and challenging urban environment. So before going to case study, basically I would like to highlight that all the 4 stations in this package are unique in their own way. Out of this, I will briefly discuss 3 stations, Grand Road, Girgaon and Kalbadevi, which were constructed using the NATM method. And each station was addressed to a solution adapted to the very site-specific ground conditions and realities. Okay. CST is done with a conventional curtain cover because it has been constructed in the Azad Maidan, which is the open ground. So there is no issue for this. So Coming to first, I will go to Grand Road Station, because here also NATM has different several difference. This is a station 3D view, which is a beam model view. Here our station, here combination of curtain cover box and NATM platform caverns connected with NATM bodies. This is the proposal. Total length of station is 225 meter, and depth is also very high, which is 28.5 meter. So I'll come, this is the cross section, station cross section. You can see this 50% has been constructed using the curtain cover, and this cavern, another platform has been constructed using the NATM cavern. Because if you look into this, there is a existing buildings, and the road availability is such that we can, in general, in conventional system, the width of the curtain cover, inner width of the curtain cover box girder is around sometimes from 18 meter to 22, 23 meters, depending upon the several condition, like ridership and interchange. Everything is coming into the planning. So here what happens, we could able to make only a box of 16 meter or 15 meter box. So in this 16 meter box, we cannot accommodate both the station, staircase, escalator, all the services room. So we have to go, this is a box, and this is the NATM. So this is a one type of station. When I will go to another station, I will the Girgaon is completely different, and Kalbadevi is also completely different in terms of planning. So you can see this is the platform level plan, where we can see this is the curtain cover. This portion has been made with curtain cover. This side it is a curtain cover station, and this is made the plan in NATM cavern. And these are the cross edit what I told from curtain cover portion to the NATM portion, and the section is cavern is this has been shown in a cross section from this in it, so that you can get the a clear idea. And you can see the cavern are different sizes because of the requirement from services, architectural, all the requirement is there. And this is a basically render view, where this cyan color is the curtain cover, and all this construction has been this yellow color is with the NAT. So here also you can see there is a longitudinal section of their construction, where the it is the longitudinal section of curtain cover. You can see the escalator, big escalator and cutout has been provided here. So you can see the complexity in the planning of the station, and complexity of the basically unrestrained wall height in the stations. So this is another 3D view. You can see this is the 3D view. This is a cross-section 3D view taken from the beam model. I would like to also emphasize in this project, beam model, 3D beam model has been utilized very extensively from the planning to the execution stage. And after that, now almost all the metro projects in India are being constructed, are being planned. Planning has been done with the beam model, but this is the first in its nature who has been the beam model has been adopted. So here you can see this is the NATM cavern, and this is the curtain cover construction. So it's a 3D cut from the station, where you can see this is the one audit going from curtain cover to the cavern. Here what I am trying, the long escalator is there, so this much of portion is cut out in the slab. So your practically this wall has been designed without this slab support. So coming to geology, because geological condition is important in case of a NATM construction. So you can see there is a field granular cohesive soil up to this is the top portion, and after that there is a breccia is there, and breccia is there from the top. So here we didn't get any basalt, and the UCS value is not too good actually. It's a very weak type of breccia, and stiffness also not like a good rock actually. So this is a poor rock consideration also in this Grand Road. So now coming to the analysis and design of NATM. Basically this NATM has been designed as a finite element model. Basically, I'd say NATM is a long tunnel, long structure with constant cross section like our retaining wall and loading along their length. So the deformation in the longitudinal direction of the tunnel is very negligible compared to the deformation in the radial direction, that is a perpendicular to the excavation. So therefore it is generally analyzed the station with a two-dimensional plane strain problem with for the cross section, and the effect of the longitudinal advancement, that is a phase stability, as I explained, we are going we explained this discuss this longitudinal advancement, this phase stability of this has been done with a empirical formula provided in the several guidelines based on the experienced persons. So, but 3D modeling is a better analytical model to assess and predict the phase stability issue. But in general, plane strain problem with 2D model is good enough. Standard has been followed, that is the IS code for the design, ITA, Indian Tunnel Association, FHWA, Eurocode, and CDA has been extensively used when we are doing the modeling, design, and behavior. So, what are the modeling steps? There is a temporary work. Temporary works, that is second pile has been modeled, and the TBM has been passes. Because as I saw, there is no space for TBM retrieval and launching. So TBM has been retrieved and it has gone. So here the tunnel segment, temporary segment has been done with SFRC rings, so that later we can easily break this segment rings. And we do the after open excavation also, we construct the base slab, mezzanine slab, then destructing of the strut has been provided. Then after going to mezzanine, we started the NATM construction. We cast it first primary lining, then permanent or permanent lining casting after completion of the primary lining. Secondary lining has been cast after the completion of primary lining, and sequentially the construction above the mezzanine level has been done sequentially parallelly with this NATM construction. So here issue is that if you look into this, the issue is this rock column, because when we are excavating the NATM, the ground support is coming. This has to go like this, like this. Basically, you need to so ground support load will be transferred like this actually. Load will be transferred like this. So this rock column is a critical issue, because this rock column is very less in case of this station. This station, the rock column is there, and the stability of the rock column is an issue. Although that's why we asked to first build the wall here and mezzanine, so that this rock column can get a confinement from this already constructed wall, and it should take care of the load coming from the top of the geology. Here the key result is that NATM crown displacement 8 mm and wall convergence is 6 mm from both the sides. This is for NATM construction only I am talking about. I am not talking about the cut and cover. There is a settlement, predicted settlement is higher. This is only for NATM. And we have checked the factor of safety is 1.5 for all the cases. Now, oh, sorry, this has come. So coming to the primary support, this is the Grand Road primary support. As I saw that it is a poor quality rock, and whatever I have shown earlier, that is from the Grand Road section. Here, 4-poling has been provided. Rock bolt. The thickness of the short crease is 200 mm, and lattice girder has been provided in a spacing of 1 meter to 1.25 meter. So this is the condition, and these are the drainage pipe has been provided to drain out the water from the ground around the primary lining. So that primary lining need not be designed for the groundwater also. And as I saw, recharging also to be done from the top to mitigate any settlement arising from the lowering of the groundwater. So these are some construction photographs, few photographs of the station. These are from construction stage, NATM construction. You can see this TBM tunnel. Then they have a face, and from the face they have started the TBM analysis. And these are the construction after the completion of the station. So these are the completion station photographs. These are the long cutout, as I am telling you during the. Now coming to the Girgaon station. This is the 3D view of the Girgaon station. In Girgaon, the station is 211 meter and depth is 28 meter. Here, basically, it is also a combination of cut and cover box and NATM cavern. Here, there are 2 cavern and 1 central cut and cover box. So coming to if you look into this here. So if you look at, this is the road. In the road, we could able to make the road width is very less here compared to Grand Road. Grand Road, we could able to make a 16-17 meter wide station, but here cut and cover we can make about 13 meter also only. So in 13 meter also, one NATM cannot be provided. So our station platform is here. You can see in the blue color, this is the platform. 2 platform has been made. In Grand Road, there is a 1 platform has been made by NATM cavern. Here, both the platform has been made by NATM cavern, and these are audit provided from cut and cover. So this is the platform level plan. You can see these 2 are NATM cavern, and in this much portion is your cut and cover station. So if I can all level plans, if we look into this here, the concourse level is very narrow cut and cover, mezzanine very narrow cut and cover, and at the platform level you can see it is a wider with the help of NATM to tunnel. So here also you can, this is a longitudinal section. You can say here there is a big cutout here. This portion has been highlighted here. You can see the cutout provided by the architect here, and he was too adamant. Architect was too adamant from aesthetic points of this should be there. It's look nice. When I visited the station, I would say it's look really elegant. And after a lot of fight with architect, we could get some of the start here. You can see this some of the start has been given. Some of the slab he has provided to us so that we can make this happen. The structure design can be economized. So here also, as I told, these are the existing station, and here road is there, and it is very less, so that we have only one narrow curtain cover which can take up all the technical domain, and these are two NATM cavern for the platform. So this is the station 3D view. You can see this is the curtain cover, and including audit and NATM cavern. So in case of geology is here also Brescia and grade 4, 5 and grade 3 and better is available, similar to the Grand Road station. But here one thing is that the rock is little good quality than Grand Road in terms of UCS and in terms of elasticity of the rock. So here the problem of analysis and design is quite lesser. So in case of this design also, I have already explained you here. This is the model has been shown with a concourse, which is a basically extended concourse. It is a entry portion has been shown. So here also rock column is there, but the rock column width is little more than Grand Road here, and rock quality is little higher than the Grand Road station. That's why rock column stability issue is lesser in case of the Girgaon station. So the primary support lining support is similar to Girgaon, Grand Road, only the lattice gutter spacing, where in Girgaon, Grand Road it was 1.25, here it is 1.5 meter center to center. So that's only the difference. Otherwise, all the rock bowl, four poling, everything is similar in this case. So another point is that I didn't discuss the audit portion in the Girgaon station. So in case of here, you can see this is the main NATM tunnel, and this is the audit or cross spaces, whatever you can say it. This is the NATM platform tunnel, and this is the audit. So in terms of design of NATM stations, we can think about the basically design is simple as plane strain problem, because it is a long tunnel. But problem, design issue and detailing issue arise in the connection between the NATM to NATM. This is the NATM to NATM connection, or there is a NATM to TBM, because after this NATM there will be the TBM. After the station has completed, there will be TBM. So this connection is critical in case of design and detailing. So designers should carefully detail it. Okay. So in this case, actually, 3D modeling will be the actual will show you the actual behavior of this canal of this junction in terms of the analysis and design of the audit. But since 3D is very cumbersome, so what designer analyze the both of the things into two different 2D model and superimpose both the result and provide some margin in the design for this junction points. So coming to these are some photographs of NATM construction. You can see that what I am telling this is the tunnel portion, and tunnel and NATM. This is the junction portion, and this is the NATM portion. And this is the NATM tunnel construction. During construction, this they are making this NATM, small NATM, then big NATM has been done. And these are the some photographs of completed. As I saw, this is the long cutout portion. You can see this, how elegant. It's like it's a real picture. I have taken this picture, I think in last December or January, and you can see the finishing and everything is look like a 5-star hotel. So now coming to Kalbadevi station, this is also a separate station. This is what I explained in first slide about explain. Here events 2 NATM cabin and central cabin and small curtain cover is there. I didn't say in Girgaon station, in some of the portion, there is a 30-story multi-story building has been also planned over the curtain cover portion of the one portion of the tunnel. I forgot to mention this. Here also this is the station 3D view. Whether you can understood this is the curtain cover portion, 2 small boxes, and these are the 3. This is a central cabin, and these two are the platform cabin. So coming to here, here there is a, I am telling these boxes. These are the boxes where they get the where they get the places. They have put the boxes. This box initial stage it was higher, but this project has been delayed due to one heritage religious structure here, and it went for a litigation in the court, and it took too much time, and we need to ultimately make the box smaller here to accommodate. And it is also a I would say architect has this very fantastic job also here. Not only the structural and geotechnical engineer, architect, and our services engineers has did in all front. Not only our the client, the GC, all have done a very good job to make these boxes very less actually compared to the requirement. Here you can see here one NATM platform is there, another NATM platform, and the central cabin is there. And you can see this entire NATM as all Grand Road, Girgaon has been constructed below the building, below the existing building. I will show the buildings also during some, I think it is already 6:10. Oh, I need to go little fast. So this is the curtain cover portion. This is the curtain cover portion, and these 3 are platform level plan. I have already explained you how it is look like. This is the station longitudinal, where this is the one central cabin, and these are the curtain cover, and these are the audit or cross passage to connect the central portion to the platform. So this is the cross section. I have already shown in the initial time. This is the cross section with a curtain cover and 2 NATM cabin. I'm not going. This is one station 3D view. So this is one NATM. This is another NATM, another NATM. Then the cross NATM also. So in case of geological condition, here geology is better. We get the basalt with a good intact UCS 49.5, and the E value is also good for the rock. So here the if I am not going to this, these are the all are but same the NATM excavation. Here all the 3 NATM has been modeled in same with a sequential excavation. Sequential excavation has been modeled in the Plaxis software. People can use RS also, FLAC also, depending upon their availability and the what I said, this engineers competence on the software actually. Okay, so here you can see the wall conversion and crown settlement of NATM is very less because of the good quality rock. Rock is self-sufficient to take care of the load coming on the rock surface, excavation surface. So here you can see there is no, in terms of the primary support, there is no lattice girder, there is no core falling, nothing has been only rock bolt. and shotcrete. And shotcrete is also, I think, shotcrete is also very less actually. It is, I think, 75 mm shotcrete has been already provided, whereas in Grand Road and Girgaon 200 mm shotcrete has been provided. And I want to tell this rock bolt has been provided only if there is any suppose you have a rock mass is there, so it can come out. So you are stitching these rock masses so that this should not come out during the excavation. So these are the few construction sequence. This is a construction area where cut and cover and NATM is matching. These are the completed station. And coming to, I'll go to building condition survey. You can see, I will only show few buildings. There are several buildings there, heritage building, dilapidated building, and very bad type of building is there. This is the one building adjacent to Grand Road station. You can see this is the condition of the building, and people are staying here. So as per the BCS report, this is a very severe category of the building. And the observation is there. You can see the reinforcement export, joint separation, visible water stain, all these things. And we have analyzed due to the excavation and the tunneling, we analyze what is the impact of the tunneling in the building, which is moderate. So severe come moderate. So there is some safety protocol. We propose the rigorous monitoring, repairing, structural strengthening work before the excavation has been started. So this has been the thing. But problem is that here severe, moderate is there. This is also a problem. Basically, severe plus moderate will make this building into the very severe category. So another building, you can see this is the building. It's not in very good shape. I didn't name the building. I am only saying this is a Grand Road station. So here also there is a settlement and severe, moderate, and the safety protocol. This is another building near the Girgaon, where the severe and building age is also very higher. You can see the building. So building damage assessment and building condition survey is a very important role in any underground station. Not only in here, it is very important in the underground station. So I am showing some temporary support has been provided even before starting the construction to the building. These are the strengthening measures. Just so now coming to instrumentation and monitoring. I will say there are 3 levels comprehensive monitoring on has been adopted at underground level, surface level, and structure or building level, adjacent building level. So in the NATM tunneling method, there also we are providing the several optical targets, rod extensometer, strain gauge, and pressure cell for stress measurement, and what is the behavior of the primary support we are measuring here. And similarly, we are measuring in the surface. There is a ground settlement marker for surface, inclinometer for lateral displacement, and piezometer for groundwater monitoring. As I saw, groundwater monitoring is also very much important. We need to provide the recharge oil as well. And in the building, adjacent building, we are providing a tilt meter for structural inclination, crack gauge for crack movement, vibration sensor for construction import, and settlement marker for building response. So we can carry in, you can see the performance observation I have shown in Grand Road, Girgaon, and Kalbadevi, the theoretical settlement and the actual settlement observed during the all stages of construction. You can see the thing in all the cases, actual settlement was significantly lower than the theoretical prediction. Demonstrates basically demonstrate the effective design, monitoring, and execution of an NATM tunnel. So Coming to risk mitigation and no. Risk mitigation and control measures. So there are several risk mitigation has been taken. One is design level control. We have done is FEM based analysis. Then critical zone identification has been done well in advance. Predefined support classes for varying ground condition. Design driven by predictive ground behavior. Construction level, we have the sequential construction, top heading, benching, or invert. Control and advanced length has been controlled to limit the disturbance. Immediate installation of primary support. Arrest water during excavation with grouting. Yeah, this is also an important thing. Whenever there is a water is coming very high, we are providing the grouting to the excavation so that groundwater lowering is not too much actually. And we have done the control deformation approach in this case also. So monitoring and observation study, as I said, real-time instrumentation with different trigger values. There are three trigger values was there. One is the alert, alarm, and action level. And if certain trigger value is exceeded, what has to be done? Construction should be stopped, and it has to come back to the designer for a check in the design and the to change any design or follow the same design. There is a continuous and validation of design through field response, live utility protection, and 24/7 real-time monitoring system, and decision driven by operational method. And groundwater control, as I explained, recharge well has been provided to control groundwater drawdown, pre and post grouting in water bearing zone. Wherever there is a water bearing zone is there, we check the pre and post grouting, and our entire focus was there to maintain the groundwater balance. So contingent emitter, we have kept the standby support system and rapid response protocol. Predefined strengthening measure, that is lattice girder, forepoling, grouting. This has been ready for deploy. If we require more lattice girder, we need to have it is very forepoling. This grouting scheme has been kept as a standby. If it is ground is responding in different severe way, then we need to deploy this thing. And there is a good team coordination between the DDC, contractor HCC, and GCN client MAPL and MMRCL. I thank the GCN client for their continuous support, and the contractor has did a very good job. So what we see, strong contingency planning and exceptional team coordination were critical to managing risk and ensuring projects successful. So there are certain outcome and achievement. You can see that structural and ground control, zero damage to the building, settlement maintained with permissible limit, groundwater drawdown control within limits, FEM prediction validated by field data, innovation, hybrid NATM cut and cover interface, live utility protection without relocation, recharge and groundwater system, continuous 24/7, and team coordination. These are the achievement. These are the recognition. This is UGC 02 recognized as most complex yet perfectly executed section of line 3. So these are some, the entire corridor has been inaugurated by our Honorable Prime Minister on 8 October 2025. So now coming to conclusion, what are the key takeaway? Basically, NATM is highly effective in dense urban environment, especially in rock. Real-time monitoring is critical, not optional in such sensitive area. FEM, basically real-time monitoring should be mandatory, and FEM prediction must be continuously validated with field data, integration of multiple construction method to essential to overcome challenges, and early risk identification and mitigation drives the project success. So successful urban tunneling and underground construction is not just about design or construction, it's about continuous adaptation, monitoring, and proactive risk management. Thank you. Thank you very much for listening this webinar.
Excellent presentation, Partha. Such a difficult thing because so many players here, geologists, geotechnical, services, and the construction, planning, structures, so many things are involved. So my just question before I ask others to ask you a few questions. The basic thing comes is primarily the civil works, systems, and then EMP and utilities. And finally, the existing structures along the tunnel and the station, which of course you have done condition survey and try to strengthen them to make them safe. Now, few structures which are contaminated later, and then what shall we do for them? And then this coming to the monitoring side, you have put 24/7. Now the life of structure may be say 100 years, but these sensors that we use may not last. So how to take advantage of the sensors which can be used for a longer time, then how to store the data and then use that effectively during the lifetime. These are just few things which I would like to ask you before we ask the other people to question.
Sir, actually, I'll go for first of the second question here. Basically, this real-time monitoring has been done only in the construction stage, basically, because
Right.
in the underground stations, underground construction, the construction is very much important to because the settlement will happen, there will be damage to the building. So that's why the 24/7 was there. And I must say there is a mobile app also there, and that mobile app, if any time in 24/7 you have any trigger limit, I said there are 3 trigger limits are there. If any time that trigger has been exceeded limit, it will go automatically to all the concern the alarm into the mobile app, so that everybody is in their alert portion. Okay. So this is the thing. And for the
No, but my further thing is during construction, yes. What about the post construction? Because the structure will last for 75 to 100 years. What are the mechanisms that we need to monitor after construction of work?
Basically, if after the construction ground has take its own shape, and the settlement is also die down. Basically, die down means, I will say, suppose there is a 12-man settlement, and there is no, after construction, after putting the primary lining and the secondary lining, your settlement will never increase actually, unless there is a defect in the structure. But that's why in general, during the service life, in general, there is no settlement is there, except I don't want to name. There are 2 buildings was there. Then those has been done. Those was to be monitor the structure at the ground level. Because of the importance of the structure, they need to monitor another, I think, 5 years or something like that. Okay.
Right.
And your first question, can you repeat the first question again, sir?
See, I said the basic thing is civil work, system, then EMP and utilities. I mean, so many things. So, I mean, what are the things as expert you will see that how to coordinate all these things? Because we need that construction should be durable, and then all those things. What are the main things? Few things which you can highlight. I mean,
Sir, as I said, because there is a NATM is not a basically fast you design and sit in the room and it will be done. It is not like that. As I explained you, sir, this is
Right.
basically we need to adapt it. Basically,
Mhm.
it is a you are doing some construction. You excavate something. You check what is the ground. Uh, uh, reaction, and
Mhm.
you need to whatever you have designed, you need to strengthen that design if required.
Mhm.
You need to reduce the basically primary lining, that you
Mhm.
need to do day by day or weekly basis, depending on the excavation. One important thing is there, geologist has a very important role to
Mhm.
identify the type of the structure, joint of the structures, everything. So
Mhm.
geology, from both from designer side, both from contractor side, from client side, should be
Mhm.
available 24 into 7 for any NATM construction.
Mhm.
And this is a keynotes I want to say.
Right. Now, Vikas, a few more questions. Can you
I
tell
think
one by one?
Mr. No, I think Mr. Bhomik is also there actually.
Bhumek? Mr. Bhumek, are you there?
Yes, yes, I'm there, very much there. And
Please, please,
yeah,
I
yeah.
mean,
So I
give
just
your.
wanted to say, I mean, I must thank Partho for such an excellent, awesome presentation on such a complex subject. And, in such a short time, I think he has covered so beautifully case studies and all aspects of NATM with intricate details of some 5 or 6 stations. I mean, this is an awesome presentation, and I'm sure the participants must have been immensely benefited. Before Partho, you go to the questions, I have few questions if you can answer.
Yes, sir. Yes, sir.
One is, the of course I see one question which is same, so I don't want to repeat that about the cost NATM versus TBM. That I'm not asking. That you will answer to the Q&A. But what is the structure cost, civil work cost of tunnel per kilometer, and what percentage of it is of the total cost per kilometer of metro? I mean, underground metro. What percentage of the total cost is that of structure? And second question is, what is the impact of these seismic provisions in the cost of underground metro, particularly if I'm talking about the new, which has been withdrawn, of course, but if I say the new IS 1893, which was published by subsequently withdrawn, is there any structures or not? These are the two questions. Thank you.
Sir, the cost of the tunnel, generally, sir, cost of the tunnel is around 150 crore per kilometer. In general, sir, it may vary little, but I am talking about twin tunnel. Basically, cost of the twin tunnel is 150 kg per crore per kilometer. It varies 10% here and there, sir. This is the thing. So, because now TBM, in when we started in 2000, sir, construction Delhi Metro with TBM, that time TBM cost was very high because all the TBM was new, imported. By nowadays, what happens, sir? TBM is available. So many TBM is available in India. Okay, okay, TBM cost has been die down now. Well, it is not increasing actually, sir. So this is the thing. And underground metro, sir, I think its total cost is about 350 or 400 crore per kilometer in terms of the. It's about, sir, 40 to 50% is the cost in underground. And coming to second question, sir, new seismic code basically in underground. There is not much impact on the underground structure, sir, except if there is a liquefaction. then there is a big issue, sir. Otherwise, why I am telling, sir, in liquefaction, we need to go, the tunnel needs to be lowered actually, because you cannot make the ground improvement, because you are into the city, sir, dense city, and under that you are moving the TBM. So there is a ground improvement is out of question basically, or you can make some ground improvement from TBM itself, but I don't know that whether that is sufficient to mitigate the liquefaction. No, I don't think that is sufficient. So if there is no this thing, there is a very few, maybe a 5% cost, 5 to 10% cost implication in case of underground. I am telling, sir. I am not telling about elevated. It's only underground, sir. So
you are
there is
saying
not
5% of the civil cost or the total cost?
no civil cost. 5 to 10% of the civil cost only for the underground. There is not much.
Okay, thank you, Partha. I think you can take the Q&A from the Q&A.
Yes, sir.
Lot of
Yes, sir.
questions are
Yes,
there.
sir.
If you
Yes, sir.
can.
Yes, sir. Yes, sir. So, first question is Mr. Sivraj Pandey. What type of geological conditions makes NATM the most effective choice? Yes, it's if it is a rock, it is very better choice. Soil, I think soil you can go, but problem is that soil I have already explained. In soil, you have to require a ground improvement, otherwise it's very difficult. And ground improvement in the urban environment, if at the top is congested area, it's very difficult. If you have an area to make the ground improvement, then you can make a curtain cover, which will be the which will be good. Sivraj, what safety monitoring techniques are most critical in NATM? Do you see NATM evolving to handle deeper or more complex tunnel in the future? Yeah, I agree. NATM will handle the most complex tunnel in the future. I agree with you this. And what safety monitoring techniques? I have already explained all the safety monitoring techniques, and I have shown you 3 types. One is NATM primary lining monitoring, so the ground level monitoring, and the adjacent building or top level building monitoring, where you can predict the actual stress in the tunnel primary lining, as well as you can see the any cracks, any excessive settlement, any groundwater drawdown excessive in the by the monitoring system. So Hemant Niraj Tripathi, where is the Sivraj? Like done.
Hegde sir also says something. Nice presentation. Yeah, for
What
NATM
types of
question.
geotechnical conditions are the most I have done? Hegde sir said, thank you, sir. Thank you for NATM sequential construction. How do you get the front face? Because you can't have shaft. Sir, that's why I tell in case of Kalbadevi station, sir, the shaft has been, there are 2 shafts. From 2 shafts, we get the face. And in case of other stations, sir, like Grand Road and Girgaon, there is what we did, sir. We first construct the audit from the curtain cover portion. We get a face from curtain cover. We go the audit, and then we enter the TBM tunnel, what has been already done, and from there we make the face to construct the TBM, sir. Mr. Niraj Tripathi, thanks for very good presentation. What is the cost difference if you compare with tunnel and actually, sir, cost difference wise, it depends upon the geology, sir. It is very difficult to say what will be the cost difference, but yeah, NATM is costlier than TBM, and NATM is costlier in the TBM, and I would say time is the essence here. Basically, here we are not making the tunnel as a NATM. We are making the platform as a NATM. Okay, we should know so that, because TBM tunnel is not a NATM tunnel is not desirable for the normal tunnel because it will take much more time than a TBM tunnel. So it will delay your project. That's why I say, okay, we went only to make the TBM enlargement for platform for that. Hemen Badalkar, excellent, thank you. Thank you, Hemant. Mr. Neeraj Tripathi, good evening. Thanks for thank you. Question: what challenges does engineer face in terms of skill set on this project, and what would you suggest as key area for engineering for upskill themselves for better prepare for similar projects? I'd say we required a capacity building by all the stakeholder. Like as a IAStructE, we are doing this. It's as a capacity building, as a knowledge sharing. So I would request all the metro authorities, they should conduct such type of, they are doing, some people are doing. I think it should be done for the public in an open forum, so that people can get a capacity build themselves. What are the difficult situations you have faced while designing the NATM? How did you overcome it? It's Mr. Neeraj Tripathi has question. I said in these three stations, I will say that Grand Road station, that difficulty of the rock column that I have already explained, that was a condition, and I will thank to my team, design team. They work almost 18 hours continuously and do several iteration, discuss with construction team, and we could able to find a solution with this. So that's the thing I have facilitated in this. Otherwise, in Delhi also we are doing an ATM station where we are facing problems because of the very unexpected geology. Whatever geology we expected from geophysical survey and the geotechnical survey, the within 200 meter of station length, there is a severe difference in the geological there. So that's a problem we are facing till the construction is going on. I don't want to name the station. So there also we could. Leela Jesse, great presentation. In case of Girgaon station, you have mentioned about adamation of the architect, how many crore rupees it might have costed. No question, but I have shown a figure. I have visited. That's a too good to look. It's look. If you go to all the station of this line, 4 station, it's too good, I should say. Okay, and one of my friend from Spain was the lead architect in this project from our side, and he's too good an architect. Nagesh Madrikar, Mr. Excellent presentation. Thank you. Is it possible to construct NATM station with 2 track in the center and side platform in Mumbai geology? Basically, yes, but problem is that the NATM cavern will be very high. Then you may have to go more deeper. Even you see in the station, it's very deep. Basically, what is happening? You required a basically cavern to cavern height. If you are making the cavern width higher, with the same height you cannot do. Basically, there should be a width to height aspect in the cavern for the stability of the NATM, basically. Okay, and for the stability, you need to, if you are increasing the width, you need to increase the height of the tunnel also. And height of the tunnel, if you are increasing, then your cover should be sufficient so that ground above the ground should not collapse. Mr. Rahul Joyan, since you have mentioned it is critical area in terms of Heritage Building Act, any special arrangement done for vibration? Yes, I already said there is this time they have use a real-time monitoring system and special heritage monitoring, building monitoring, which has not been done past in India. Mr. Sivraj Pandey, how does TBM handle tunneling in highly water-bearing strata compared to pressurized? Basically, if you look into that, Mumbai is high, whatever I said, the case study. So there, NATM handle is very good. Basically, I said that monitoring is monitoring is very good. Monitoring has been done very good. Groundwater recharge well has been put. Ground recharging has been done, and grouting has been done. So in highly water bearing area, in soil, we should not go for NATM at all. We should not go for NATM at all in case of soil, if there is water is high. Okay. Hope I would be able to answer. Swapnil Vilasere. Sir, what was the most unexpected ground behavior encountered during excavation, and how did you challenge your original risk assumption? So, basically, what I am this is the I already explained you one example. In case of Mumbai, we have not faced. I have already seen the predicted settlement was higher than the actual settlement. So there is no unexpected ground behavior, except in some places we have seen the water ingress is very good, very high than what has been integrated. We have done the seepage analysis also during the design stage. So in the seepage analysis, whatever the water ingress we check, that there's in few of the location the ingress was too high. So there we did extensive grouting in this location actually to mitigate this. But yes, in Delhi, I have just mentioned, there we get a very unexpected behavior in this case actually. Behavior in terms of prediction, the settlement has increased, and we need to go for grouting. We need to additional support, and there. Sir, is it economical to construct? No. Mr. Harris has question, sir, is it economical to construct NATM soil? I said say no. It is not economical, and it is sometimes it's risky also, depending upon water table. Professor Tandon sir has question, great presentation. Thanks. You are right. Both design construction much more complicated and higher cost than TBM. Thank you, sir. Flaxis 3D almost impossible to comprehend and apply in the region meter. Absolutely, sir. Absolutely, sir. Flaxis 2D is why Flaxis 2D is better, because in this problem we can Flaxis 2D has a reasonable return, and Flaxis 3D it's basically time consuming and it cannot done. Absolutely, sir. Thank you, sir. Thank you. Mr. Rahul Join, sir, please tell in terms of train operation after the ROD to lessen train vibration is special as was done, like spring system, etc. This is a track design. Track design. They have provided a MSS system in some of the portion of the track to mitigate this track vibration. It has been done during the track design. Mr. Sivraj, thank you for your valuable time. What are the hidden cost of NATM that is delayed due to monitoring, skill, labor requirement? Yes, it is a considerable cost, because I would say it's a considerably cost. Sometimes what happens, I would not say in Mumbai also, one portion has been delayed due to the much more water ingress into this, and in Delhi, whatever I am telling, there also, sir, NATM due to NATM. But there was no where we should go for NATM. We should go for NATM where cut and cover station is not possible. We should not go NATM, just I need to do a NATM. This is not the idea of the NATM actually. we should understood this. We should only go to the NATM where any other solution is not available. So we should know. I think one chat box somebody has sent in seismic design. Yes, seismic design has been done. I have not envisaged the seismic design because seismic design tunnel and NATM is not different. Seismic design has been done as a method prescribed by HASAS, where the seismic has been done as a strain compatibility method rather than a inertia method we used for the elevated station. Here, seismic analysis is for the strain compatibility. We calculate the strain based on the shear wave velocity, and we apply those deformation into our structure and calculate the seismic forces. And one thing is that there is no plastic hinge formation allowed is applicable in the underground construction. Ms. Leela Joshi, but at least for infrastructure project, engineers should be on the driving side. I believe that a really talented architect can add waste access to any structure without. I don't, Ms. Joshi, I don't want to go into this discussion today with our architect and structure, but I would say he agreed for the requirement of structure, our architect, whatever we are asking to them. So, Venkat sir has question, Hegde sir, final question, Partha. Right now, there is a complete breakdown of mobile connectivity presently in line 3 of Mumbai. Can you suggest a solution? Sir, we need to provide the client need to tie up with the mobile companies to to basically install the booster in the underground station so that mobile connectivity is there. You are right, absolutely right. Mobile connectivity is not there in the entire line. Mr. Sivraj Pandey, how do contextual frameworks like design, build versus EPC affecting NATM implication? Basically, I would say NATM requirement in underground line 3 of Mumbai Metro was prerequisite in EPC contract. And there is no other. Basically, client and GC has taken it into consideration where the curtain cover is not possible, there only they propose the NATM. But in case of Delhi, there is a design build contract where contractor changed the design from curtain cover to NATM to reduce the curtain cover depth. There they have proved that they don't require a additional cost. So it has to be client will only agree if they don't need to pay additional cost, or else we need to contractor or a DPC contractor need to prove that curtain cover is absolutely not possible. Sir, any mistake and initial planning or assumption that had to be revised during execution under Mr. Sapnil, basically mistake, I will not say any mistake in the design of NATM. As I say, NATM is based on the ground response actually designed to be done around. So because you cannot do all the ground investigation, because if you see in the NATM is passing through the densely condensed building, so you cannot get the borehole at those locations. Even you cannot do the geophysical also. That is because for geophysical also you need to do the cross hole to hole, and people are not allowing to make the cross hole into their building or their premises. So that's a problem. So it's I would not say mistake. Yes, there is an unexpected geology we also faced, but in Mumbai it was never gone a bad way. But yes, in Delhi we faced a quite problem we are still facing. Okay.
I think Engineer Partha, I tell you, people who are listening must have got a lot of benefits. So,
Dhawan Sahab, if you allow me, I just want
please,
to
please,
sort of
please conclude.
give
Please.
some remarks on one of the comment raised by Leena Joshi about who should be in the driving seat, and where Partha said that he would not like to. It's a sensitive matter, but let me put my neck out and give my observation. I think there is no doubt that infrastructure projects like underground. There is no doubt. There is no element of doubt that the engineer has to be in the driving seat. But at the same time, I mean, it's a teamwork.
Yes.
So involvement of a good architect can only complement and supplement the work of the engineer. The architect is not replacing the engineer. No,
Yes,
no way.
absolutely.
But he can definitely supplement and complement engineering work and make the structure look beautiful. And that is very, very important in metro structures. Thank you.
And I want to just tell you one thing. My friend from Spain, he was a very clear understanding of structure, and but I must say I have not seen such architect for a long time, sir. And I need to make a fight, sir. Forget about my team, sir. I need to make it fight to give something because he is too good, sir. I would say in architecture he's good. In structural sense also he know where he need to put, where well, we are asking more actually, sir. That's the thing.
That's very important.
That's very important actually, sir. And such structure, if you look into such structure, as I saw, sir, that NATM architect is very much dependent on us, sir. One structural geotechnical, because the geometry should not
Yes.
be what the architect has to divide. They only
Right.
tell, I require this, I require this. So I need to make, as I explained in first, I started from small, then I need to go higher, I need to go higher. So it's always a space proofing to be consultant with the MEP and architect teams.
But at the same time, Partho, just
Yes, sir.
as you mentioned that a good architect has a good idea about the structure also. So he knows what you actually are looking forward
Yes,
to.
sir. Yes, yes.
Same way, I think a good engineer must have a fairly good idea about what the architect has in his mind.
Yes.
I mean, this applies to not only underground structures, but also elevated, structures, metro, station building, whatever you call, even buildings. I mean, a successful engineer is the one who can, gel with the architect and understand the architect's requirement also.
Yes, sir. Yes, because, sir, we are making the civil infrastructure to train to run and the processing. So we need to understood the services, architectural evacuation, all the requirement also.
Yeah.
Otherwise, it's very difficult. Otherwise, we will say, "Arey, cut out. Why we should get cut out? Why he is asking cut out?" But cut out is part and parcel of such type of structures.
Absolutely.
Yes.
Absolutely. Thank you. I think, Partho, I must once again thank you for such an excellent presentation on such a difficult subject.
Thank you, sir.
Partha, again, I must compliment and thank you for sharing your knowledge and with giving emphasis on the capacity building of all the players who are involved in such construction. So, with that, let's conclude.
Thank you, sir. Thank you all.
Thank you, sir.
Thank you.